Hi, this is Alex from devstories.eu. Async.io, episode 20 of 20. You hit a performance wall with your asynchronous code, and profiling points directly at the core event loop itself. You cannot rewrite the standard library, but you need lower-level control over exactly how the system handles sockets and tasks. The answer lies in extending and custom loops. The standard Async.io event loop is not a hard-coded black box. It is an extensible interface. It was designed from the ground up to be fully replaceable by high-performance C libraries or specialized Python implementations. Most application developers will never need to build a custom loop. However, if you are a framework author or you are building an optimized loop like UV loop, you need to bypass standard behavior and integrate directly with lower-level operating system primitives. To build a custom event loop, you start by subclassing BaseEventLoop. This base class defines the entire contract for how asynchronous operations must behave. By inheriting from it, you get the structure, but you can override specific methods to intercept and redefine fundamental operations. Consider socket creation. In a standard application, you ask Async.io to open a connection and it uses the default Python socket implementation. But in a custom loop subclass, you can override the network creation methods. This means when the application requests a network connection, your custom loop intercepts that call. You can then route that request through highly optimized C code or tie it directly to advanced kernel features that standard Python does not expose. The application code does not change, but the underlying machinery is entirely yours. This granular control also applies to task management. Here is the key insight. The event loop is responsible for tracking every single asynchronous task. If you look under the hood of BaseEventLoop, you will find an internal method called _register_task. By overriding this specific method, your custom loop intercepts a task the exact microsecond it is created. Why does this matter? If you are building a custom runtime, you might need to track deep diagnostics, implement specialized memory pooling for tasks, or send task state directly to a custom monitoring service. Overriding _register_task gives you a guaranteed hook into the lifecycle of every coroutine before it even begins executing. You can also override the corresponding unregister method to handle cleanup exactly how your framework requires. Once your custom loop class is built, you have to tell Python to actually use it. You do this by creating a custom event loop policy. The policy is just a factory that dictates which loop implementation gets created when a thread asks for one. You set your custom policy globally. From that point forward, any standard library function that requests an event loop will be handed your optimized custom version. The true power of Async.io is not just the async and await syntax, it's the fact that the entire execution engine is a pluggable interface ready to be swapped out the moment standard performance limits your architecture. Since this wraps up our series, I encourage you to read the official documentation, try extending these components hands-on, or visit devstories.eu to suggest topics for future series. That is all for this one. Thanks for listening, and keep building.